Hello everyone, how's it going? My name is Dan the Tutor. In today's video, we're going to be talking all about power. Not just the equation, but also a couple example problems to get you through it. So the first thing I'll mention about power, you use it at the end of the work unit. Remember, work in physics is defined as a force times a distance times cosine theta, if there's an angle. And now we have power, where power is defined as work divided by time. In other words, you can also write power as a force times a distance divided by time, or you could even write it as power equals force times velocity, and you get that if you realize that d over t, distance over time, is equal to velocity. That's how you get this third equation. So my advice to you is to memorize these two versions because these are the two that you most commonly see in any physics question. And the last thing I'll say about power is that the units are the watt, capital W. And now let's look at some example problems on power. So for the first one, let's say I'm dragging a box with a force of 20 newtons. Let's say I drag this box a distance of 5 meters. So now it's over here now. And we do this in a time of 2 seconds. And my question is, find the power. Okay, so I could not have started with an easier problem. Clearly, we're going to use the equation power equals work over time, where work is equal to a force times distance. So that means power is equal to force 20, distance is 5, and the time is 2. And there's no cosine theta here because I'm not pulling at any angle, so I don't have to worry about that. Plugging this in a calculator, I will get an answer of 50. The units are watts, capital W, and that's it. Easy as that. So now we're going to look at a harder problem. For this one, let's say I want to run up a flight of stairs that is 10 meters high. We'll say that I have a mass of 60 kilograms. And if it takes me 6 seconds to climb the staircase, how much power did I do? So to solve this one, we're going to use the same equation, power equals work over time. But the problem is we don't know what the force is. But we can find the force if we do a free body diagram. The forces acting on this person are mg going down, force of gravity, and a normal force pointing up, Fn. And these are really all the forces that I care about. Now you may be thinking, doesn't Fn, normal force, have to be bigger than mg to climb the stairs? And that does make logical sense, I will agree with you. But the secret to this problem is realizing that these two forces are actually equal to each other. Fn equals mg, force of gravity. The reason why is, if, let's say, I'm climbing the stairs at a constant speed, the only way you can have constant speed in physics is if the forces going up equal the forces going down. Normal force equals mg. Now you may be thinking, but it doesn't say constant speed anywhere. And you'd be correct, actually. But the thing you're not realizing is that obviously I'm speeding up as I go up the stairs and then slowing down as I get to the top because I'm stopping at the top. Then this averages out to a constant speed. Or in the very least, it averages out that the normal force equals force of gravity. And you may not understand completely why or what I just said or what my explanation was. But I am telling you, the secret to this problem is that these two forces are equal to each other. This is a massive assumption we're making, but it is the secret to answering this question. And I remember when I got this question wrong on my college physics test, this is what I should have done, and I didn't do this, and I got the wrong answer. So now I'm telling you, do this. And because of that, the normal force is the force we are looking at, is the force going up the stairs. So then the power is going to be work. Work is force times distance. We're saying the force is mg, and I know my mass is 60 times 9.8, which gets me 588 for my force. So in other words, power equals 588 times the distance, which is the height of the stairs, 10. You may be wondering, but Dan, this is clearly at an angle. Do I need to find the hypotenuse to find that distance? And again, the short answer is no. I only care about the distance going straight up. And the reason why is because that's the way the normal force points. Normal force points up. Even if it did point at an angle, I would need the component going in the direction of force, which is straight up. And if I did give you an angle, then the cosine of theta would have covered that. But obviously I didn't give you an angle, so it would have been impossible to find that anyway. So long story short, use 10 for the distance, use 588 for the force, and then the time was 6 seconds. So then we can find this power, just plugging this in a calculator, and I'll get power of 980 watts. And that's it for that one. Not an easy question. We did make a couple of assumptions, but this is the secret to this problem. I'm just telling you. And now we got one more question we're going to be looking at today. For this question, it is going to be a graph question. On the x-axis is force. On the y-axis is a velocity. And what this graph is going to look like, it's going to start right here and then go down to 0 like that. Let me give you some numbers now. This number here is 10 for velocity. We're assuming meters per second. Here the force is 30. Again, we're assuming newtons. And here the force is 40. And my question is, what is the power for this scenario, for this graph? So I'm going to tell you, whenever you have a graph question, it either means we're looking at the area or the slope. In this case, because it's force versus velocity, and we know that equation power equals force times velocity that I mentioned earlier, whenever it's multiplication like this, it is going to be the area under my graph. So I got to find this area right here, probably by splitting it up into two different shapes, a rectangle here and a triangle here. The area of the rectangle is just going to be height times width, 30 times 10, which is 300. And then the area of my triangle is 1/2 base times height. The base is not 40. The base is 40 minus 30, so it's only 10 is the base. And the height is 10 as well, giving me 50 for the blue triangle. All I need to do now is add these areas together. 300 plus 50. Final answer is 350 watts. Now I do want to tell you, just because it's a graph does not mean it's automatically force times velocity equation. And likewise, you can use this equation, power equals force times velocity, even if you don't have a graph. Just depends what the problem gives you in terms of the given information. But that's it. I encourage you to go off on your own now and find some problems you can try on your own. So thank you all for watching. Have a great rest of your day, and I'll see you in the next video. Take care, and bye-bye.